Proper testing of concrete before and after construction is an important aspect of performance-based durability design of concrete structures. In South Africa, a suite of 3 tests is used. These are the oxygen permeability, the water sorptivity, and the chloride conductivity tests. Each test gives us a durability index parameter. Each durability parameter is linked to a transport mechanism relevant to a particular deterioration process. The performance-based durability design approach links these durability index parameters to service life prediction models and performance specifications. This video presents a demonstration of the oxygen permeability test. The specimens used in these tests are circular concrete discs prepared by coring and cutting of concrete cubes in the laboratory or by taking cores from concrete elements on site. The specimens are typically concrete discs which are 70 mm in diameter and 30 mm in thickness. The disc specimens are dried in an oven at 50 degrees centigrade for at least 7 days, but not more than 8 days. Sample preparation is not covered in this video, and you are encouraged to read the relevant literature on this. Before the test, the diameter and thickness of each disc are measured using a vernier caliper. The disc specimen is placed in a falling head permeameter like the one shown here. The oxygen permeability test consists of measuring the pressure decay of oxygen passing through a circular concrete disc specimen like the one shown here. The permeability cell consists of 4 important components. These are an inlet valve, an outlet valve, a pressure gauge, and an oxygen gas chamber. The oxygen gas is supplied from a pressurized cylinder. It is important to ensure that the disc is placed correctly in the compressible collar. This is done for 2 reasons. The first reason is to ensure that the outside disc surface will be in direct contact with the oxygen in the gas chamber. The second reason is to ensure that the correct volume of oxygen is contained in the gas chamber at the beginning of the test. The compressible collar assembly is then placed in the permeability cell. The top screw is then tightened to ensure air tightness between the disc specimen and the compressible collar. With both the inlet and outlet valves open, allow the oxygen gas from the supply cylinder to flow in and out of the gas chamber for about 5 seconds. This will force out air contained in the gas chamber to ensure that only oxygen gas is contained in the gas chamber. After 5 seconds, close the outlet valve and let the pressure in the gas chamber rise to about 100 kilopascals before closing the inlet valve. Ensure that there is no pressure drop of more than 5 kilopascals per minute. If the pressure drop is more than 5 kilopascals per minute, you should find the source of the leakage before proceeding with the test. Common sources of leakage include a cracked disc specimen, insufficiently tightened top screw, and faulty valves. Take note of the time of starting the test. The pressure drop in the gas chamber should be recorded at 15-minute intervals throughout the tests. The recording of the pressure drop in the gas chamber can be done manually, or it can be automated using a suitable data logger. The test is terminated when whichever one of 2 conditions is met. The first condition is if the pressure has dropped to about 50 kilopascals. The second condition is if at least 6 hours have lapsed since the start of the test.